We can then start the webinar. So thank you for joining us today. Again, I'm Dan Schrader. We're here to talk about software-defined networking. This is an overview presentation. If you have more questions about software-defined networking or anything else that Vyatta does, you can contact us after the webinar. You can send a note directly to me, dan@vyatta.com, or you can contact sales@vyatta.com. Of course, we need to start with our obligatory legal disclaimer. I'll give you all about 5 seconds to read this. Don't worry, no pause, no quiz at the end. And I'm going to pause here because I'm getting a note that my screen is being paused by GoToMeeting, and I need to find out why that is the case. Good morning, everyone. I'm Dan Schrader, and we're here to talk about software-defined networking. Here's the legal disclaimer. You can read this at your leisure afterwards. The network's in my way. Here we are in the world of rapid application development, massive virtualization, hybrid cloud computing, and our networks are in our way. Designing, deploying, changing networks to meet changing business needs is still mostly a manual and sometimes a painful process. We need a new model. And here's a bold prediction. That new model is going to include something that someone is calling software-defined networking. All right, perhaps that wasn't actually such a bold prediction. I don't seem to be able to open up my browser in the mornings without seeing another headline about SDN. Now, granted, I could change my home page, but that wouldn't change the reality that you can't take a step without stumbling over another SDN announcement. So what is software-defined networking? Well, according to Ivo Pepelnjak, I hope I'm pronouncing his name correctly, SDN is about programmable networks, more precisely, network elements that can be configured through a reasonable and documented set of APIs. Well, that's a start. I don't know if that's quite a sufficient definition. The Open Networking Foundation goes a little further. They say that software-defined networking is an emerging network architecture where network control is decoupled from forwarding and is directly programmable. All right, so software-defined networking is characterized by programmability, and it's characterized by a control plane that's abstracted from the hardware or other networking devices. The point is to allow programmatic control within infrastructure. I'm still not sure it's a complete definition, so let's talk about what SDN is not. SDN first is not a substitute for smart network design. If anything, expectations are getting ever higher. Network engineers are going to have to get a lot closer to the application developers to meet those expectations. Second, it's not just about OpenFlow. OpenFlow is a useful and important technology that is part of the set of tools that may allow programmatic control of networking elements, but just because you support OpenFlow doesn't mean you are completely embracing SDN. So if we go into a more complete definition about SDN, it's about network programmability, and not just programmability. It's about doing it in an open way so that you're agnostic to the vendors. It's about having an open set of APIs that interact with all the network elements. It's about separating the control plane and the forwarding plane, which turns out to be a necessary element in programmability. The forwarding plane can be a hardware traditional networking device, or it can be a software-based device, such as those that Brocade and Vyatta come out with. The control plane, though, needs to be agnostic to the underlying hardware. If it's a single vendor-only solution, it isn't truly embracing the concepts of SDN. It's about an integration with higher-level orchestration platforms, such as OpenStack, CloudStack, vCloud Director, whatever Microsoft's going to come out with. These higher-level orchestration platforms give you a higher-level view of the overall network architecture and the ability to modify, change the network to meet your business needs. And it's about a network topology and an orchestration that's derived from the application, from the tenant. And this is really how SDN is different from traditional networking. It's that the business is driving the network, not that the network is driving the business. Oh, and as I mentioned before, it's about a certain amount of vendor independence. A lot of the SDN movement has been based on open source technology. That's going to continue to be the case. It isn't necessary, though, that every element is open source. What is necessary is that the world complying with a common set of APIs, an open set of APIs, so that products from different vendors could work together seamlessly. So what's driving SDN? Well, it's not about agility. You're going to hear a lot of vendors talk about how SDN gives you the ability to add new services, to modify your networks to meet business needs, to do this all in a click of a mouse, and it's all true. And that is an important driving goal of SDN, but it's not really the driving goal. It's not about new services, which is probably another way of talking about agility. What SDN is really being driven by is the economics of network. It's about organizations not being able to keep paying the high capital costs, sometimes called the Cisco tax of networking. It's about the out-of-control energy costs that are unsustainable. It's about the expensive real estate. It's about the overall operating costs of having very talented and expensive networking personnel pulling cable or sitting at a monitor writing command line instructions every time they need to change the network. So if we look at today's networking model, we see the network as a set of monolithic networking devices, routers and switches, each with its own control and forwarding plane. Now, by design, each network device knows only its immediate neighborhood. Sure, routing protocols such as BGP and OSPF provide some route cost information that allows each device to choose the least cost route path. But the least cost path isn't necessarily the optimal path. And those routing tables don't know anything about the changing values of different applications or tenants. What this model lacks is an end-to-end awareness of the network. It lacks programmability. It lacks the ability to dynamically change in an underlying way. What I'm saying is that there's no higher level abstraction layer. And that leads nicely into what is the SDN model. In the SDN model, each device becomes a forwarding device, each controlled by a standards-based set of APIs. Each device can be hardware-based, can be a hardware-based router or switch, or a software-based networking device. In an SDN model, there's a control plane, an application that's abstracted from the network. It's probably running on an x86 box, or it's running as a virtual machine, and it has the ability to interact with all the networking elements. The control plane, in turn, has its own set of common open APIs that allow it to derive intelligence from applications to be managed, and in turn to be controlled through an orchestration layer. The control plane provides that higher level abstraction layer that represents the entire network as a service. Think of it as networking as an on-demand programmable resource. Now, no one vendor, and I don't know why Nasira shows up first in the slide. I need to fix that. No one vendor can provide the entire infrastructure of SDN. We're going to need an ecosystem of SDN-enabled technologies, and that includes a common set of networking elements, both hardware and software products that support open flow and similar technologies so they can be controlled programmably. And so they're designed so that they can act as forwarding devices where the control is abstracted to a control plane. It's going to be about tunneling overlay technologies such as VXLAN and NBGRE and STT that allow us to extend the network in ways we previously couldn't. It's going to be about having a rich array of controlling technology, whether it's floodlight, daylight, products from particular vendors, or products from an open source community that can work with those underlying networking elements, and in turn have a northbound set of APIs that allow it to be centrally monitored, managed, orchestrated. And that's going to be working with both orchestration-specific technologies like OpenStack or CloudStack, and with specific applications such as network analytics, network monitoring tools that can tell the network to change based on changing business realities. So how is SDN being used today? It's primarily, frankly, being used in the lab. There is carrier-grade SDN that is being rolled out by some large service providers using, WAN programmability and an open flow path. There are a few enterprises that have started playing with SDN-based technologies, but frankly, it takes a lot for enterprises to change what direction they're heading. Now, most of those are still research projects, but we're starting to see a few enterprises and a few cloud service providers, particularly some of the more advanced ones, who are employing either, usually some hybrid SDN environment, but more and more we're starting to see announcements of them actually moving to a full-scale one. And not surprisingly, we do see that the cloud service providers are a lot more open to new technology, new techniques than perhaps the enterprises that have a day business to run. But mostly we're seeing SDN in research environments. So why is SDN important? Well, they're important because data center networking technologies are changing, or they need to change. This massive push into virtualization we've seen over the past decade is leading to ever greater server density, and greater server density means a lot more servers sitting on the same hypervisor, and a lot greater percentage of networking traffic is going between servers within the hypervisor. That is east-west traffic as opposed to north-south. And that's part of the changing traffic flows we're seeing in the modern data center. But even more, SDN is important because the cost of networking is out of control. As businesses are being asked to react more quickly, as cloud service providers need to be able to roll up new tenants on a moment's notice, or even roll them down or modify their topologies, it gets to be very, very expensive to start buying new routers, firewalls, and switches every time you get a new customer, or every time a new business, your business changes. But maybe the most important reason outside of the economics is that network operations need to keep pace with DevOps, and it hasn't been. It's about the economics of networking. So where are the savings? Well, it's hard to say. Savings are going to vary tremendously based on the kind of organization you are and how far down the path of true SDN you followed, and what are a lot of the decisions you made along the way. But Brocade did try to make an attempt to quantify some of these savings, and we do on our website someplace have this research from ACG Research that looks at what kind of savings one could theoretically get from an SDN environment. And they broke it down into three different ways of using SDN. First, where the primary purpose was service creation and insertion. The second, where WAN virtualization was the primary objective. And the third was to have networks that would be controlled and monitored and improved through network analytics in a programmatic way. And they found that the total cost of ownership savings from SDN varied significantly depending on what you're trying to do. If you're primarily interested in making sure your network's running smoothly and having a network analytic-based network, you could see up to about a 48% savings. If you're looking at WAN virtualization, we're seeing a total cost of ownership savings around 61%. If you were looking to go the full use the full SDN capabilities and use it not just for analytics and virtualization, but for service creation and insertion, you may see savings as high as 83%. We see service velocities increased by reducing order processing setup from 1 year to 4 months, and for a 7-to-1 reduction in order processing time. One useful quote from the survey. So if we look at the early deployments approach to SDN, we see that there are usually highly virtualized environments where they're deploying vSwitches on top of a hypervisor. This could be, an open vSwitch. It could be something from VMware and their vSwitch, or other proprietary solutions from other vendors. We see these vSwitches being controlled by a central controller. And we see connecting layer 2 segments using VLANs or some emerging layer 2 encapsulation technology. The controller allows the connection of virtual machines to layer 2 segments in a pretty flexible way, allowing fully segmented, isolated networks to share hardware. And that's a tremendous goal. What's not fully addressed here is how to connect these new networks together to the networks of today or to each other. or how to go between these islands of SDN and how to connect seamlessly with traditional legacy environments. And that's where Vyatta comes in. Vyatta provides a software-based networking solution that uses protocols that you're familiar with. We're using BGP and OSPF to connect existing networks, and that provide a routed hop between those layer 2 segments. Vyatta includes a stateful firewall so you can securely transition between networks without violating your security policies and without you extending your PCI compliance to embrace some giant layer 2 network. Because Vyatta is in software, architects can put these networking elements anywhere in the network. And as a software-based solution, we can be deployed as needed, we can scale easily. If you need to move a Vyatta image, you can do that. If you need to delete it or change it, you can do that, and you can do it programmatically. So how is SDN being used today? Well, what does Vyatta do? I'm sorry, I forgot I inserted this slide. Vyatta delivers networking functions in software, and there's a term for that. It's called network function virtualization. Network function virtualization allows you to take a highly virtualized environment where you virtualized your development environment, your QA environment, your production environment, you've got web tiers and application tiers and database tiers, and they've all been virtualized. Everything's virtualized except the network. Now you can virtualize the network itself. In fact, we even have customers that have taken this entire virtualized data center and templated it so that they can roll out new data centers on demand. What is Vyatta? Vyatta is a firewall, it's a router, it's a VPN, all built on common standards. It's one product that delivers a network infrastructure with the flexibility and economics of software. And it's used primarily by highly virtualized enterprises and by cloud service providers. Who are we? We're a Brocade company, and we're the leader in software networking. We were founded in 2006 on the belief that the future of networking is software. The Vyatta technology is used in thousands of production networks, everything from small research environments to some of the largest networks in the world. We've had over 1 million downloads of our technology. We are a Brocade company. Vyatta was founded in 2006 as an open source solution, and we still have a rich and vigorous open source community that you can visit at vyatta.org. However, we also have a lot of proprietary technology as well. We provide a server and hypervisor agnostic approach, enabling agile capacity on demand networks. And I'm glad that was written on the screen because that was a mouthful. We provide software networking, including routing, firewall, and VPN. We're based on open architectures, and we support open standards. The product provides a rich array of advanced routing and security functionality, supporting both IPv4 and IPv6. We've got strong VPN technologies, allowing you to create robust cloud bridging at both Layer 2 and Layer 3. We can be managed through a command line interface that you'll find very familiar. We have a complete set of RESTful APIs that allow you to control the entire environment and a graphic user interface. We run on all major hypervisors, and we run inside of all major clouds. So remember when you used to get excited about networking? I think now that we're in the age of SDN, it's that time again. And that seems like an excellent time to allow you to ask some questions. We finished the presentation. You can click on the hand icon in your upper left-hand, upper right-hand side to let me know you have a question, or you can enter a question into the box. And let's see if we're getting any questions. All right, so I'm getting one question here. What is the difference between open source and the paid version of Vyatta? The products are built on a common foundation. The open source product is a very functional router, firewall, and VPN. It lacks some of the key technology that Vyatta has, that the subscription edition has, and more importantly, there's not someone to pick up your phone if something goes wrong. Vyatta offers world-class 24/7 support. We offer additional functionality such as a graphic user interface, RESTful APIs, additional authentication technologies, and the next version, which we'll be announcing in a month, they'll have some additional proprietary technology that you're going to really want to have your hands on. So I do recommend trying the subscription edition, and you can download it from Vyatta.com. Someone is asking, what is vPlane? vPlane is a technology that Vyatta announced that separates the control plane from the data plane. It's not in a shipping product yet. However, it's in the testing phase, and we'll be talking more about it, at a future time. Okay, will Vyatta work with Brocade products? Yes, both Vyatta and Brocade support common networking standards. We're not doing anything proprietary, so we do support, we will work together, and we do have reference architectures that we can help you with if you contact someone in our sales organization. I see Fred is asking, where does Vyatta actually have the ROI numbers to support SDN savings in the earlier chart? Well, Vyatta is not a complete SDN solution, is the honest answer. Vyatta is a step to SDN. Software-defined networking implies that some of your networking elements are going to be in software, and Vyatta is a software-based networking solution. We cannot yet say we offer you those complete return on investment savings. We are not a controller. We are not an orchestration layer. We're not an application that can control those. We're a networking element. So, we are one piece of the puzzle, and we'll offer you some of those savings that you're going to get for if you get to SDN, because you can add, remove, delete us, modify us programmatically, but we're not a complete SDN solution. Are there any other questions? Someone's asking where they can use Vyatta. You can download a trial version of the subscription edition from Vyatta.com. And you could go to Vyatta.org for the open source edition. Someone is asking if the vRouter is a distributed architecture. No, the vRouter is a traditional architecture. It is so it's more of a traditional router, firewall, VPN, just like you're used to working with, except it's based in software, and it's a Linux-based technology, and that gives you tremendous ability to script it and to integrate it into other technologies that you're using. Fred is now asking, do you see other applications like intrusion detection or malware? I guess he's asking if we see us integrating that into Vyatta. Vyatta does include URL filtering as part of Vyatta Guard. A previous version did have intrusion prevention, and frankly, it wasn't working out well. That's a very resource-heavy technology, and we had to remove it. We may revisit that question, or being a software-based solution, we may decide to integrate or find some other links from other vendors. All right, and the same could be said actually about malware detection. I think there was a previous version of Vyatta that supported ClamAV. We're not supporting it right now, but if there's enough customer demand, we may revisit that question. Don't take that as a promise. All right, are there any other questions? Well, we seem to have concluded this today's webinar and gotten to it right on time. We have one more webinar in our series. Next week we have Brocade's Chief Scientist, David Meyer, who's going to be talking about the future of networking. He gives a very interesting view into what is driving changes in networking and what's going to change it in the future beyond just SDN. So I do recommend it. Here's someone asking if the Brocade Vyatta vRouter components are controlled by OpenFlow. No, we do not yet have those components controlled by OpenFlow. There is going to be an announcement regarding Vyatta and OpenFlow in the near future, but you're not going to see a product right away that supports OpenFlow. All right, I think that's everything. I'm just going to take one more look and see if anyone's hands are raised, and I need to unmute their phone. And no, I don't see anyone. So that concludes today's webinar. Thank you for joining us today. You've been a terrific audience. I appreciate you taking your time out to come listen to us. We have one more webinar in the series, and then we'll be starting webinar series again with fresh content and fresh webinars in June. Thank you, and enjoy the rest of your day. Oh, I see one last question coming in from Suresh. I'll hold for a second before I to give him a chance to ask it. I'll unmute his phone. Yes, Suresh. I'm not hearing you. Are you talking? Is your phone muted? Well, I guess we don't have a last question. If you do have any last questions, he's asking if you can tell me more about the RESTful API. The RESTful API is available only in the subscription edition. Excuse me?
Yeah, sorry, I was muted. Can you please tell me how about the RESTful API such as which would contain components and what are the RESTful APIs for?
I'm sorry, there was a tremendous amount of static on that line, and I couldn't understand that. I think he's asking more about the RESTful set of APIs, because I see that it's been typed into the question pane. Probably better if we go through that more offline, but it's only available in the subscription edition version of the product. It does allow you to control virtually every feature of Vyatta and to integrate Vyatta into other orchestration systems and to other technologies. All right. With that, we're going to conclude the webinar today. Once again, thank you, everyone. Enjoy the rest of your day.